3.2. Again, there's going to be a lot of cutting and pasting in this only because, like I said, I'm just not a fan. Like, this is not something that we enjoy doing, but, you know, let's highlight some specific things. We do need to know what factor form is. Our factor form is right here, where we have two binomials multiplying each other with the leading coefficient a, and of course it's saying that a cannot be 0. Okay, R1 and R2 represent the x-intercepts, which is what we talked about before. So let's do it. Determine the zeros of the function z of x equals x squared minus 16, and then we write it in function form. So I'm gonna get my Desmos because I want to see the zeros of the function. Z of x, I'm sorry. Z of x equals x squared minus 16. Here's my graph. I typed this in very nice and neat. Here's my graph. My zeros are my x-intercepts. I click those, -4 and +4. Okay, I'm gonna write those coordinates down. So my zeros, we had -4, 0, and 4, 0. After that, we want to be able to convert this into factor form. X equals -4, x equals 4. Of course, we want it to be our 0 because that's the name of what it is, so I need it to be 0 on the side. Add 4, add 4. There's my 0. X plus 4 is my first part. -4, -4. There's my 0. X minus 4 over here. So we got our two pieces of information, which is our G and my H. Now, leading on to the next part in part 2, we should be able to eventually figure out that these are my linear lines, okay? So G of x is x plus 4, and H of x is x minus 4. 4, -4 are my intercepts on my y, but they also represent my zeros, okay? So these are my linear pairs, my linear factors, okay? Now, don't forget, because I almost forgot right here, factor form is z of x equals x plus 4 times x minus 4. Of course, if you did the box method, it'll give you that answer right there. Okay. Again, I don't know why they want us to fill out this table, but just because you know we need to do it, it's -4 plus 4, which is 0. -4 minus 4 is -8. -4 minus 16. I'm sorry, I forgot the square. I think that's, give me 1 second. It says 0. And you just want to fill out the rest of the table. Here's a work example that we just talked about. I found my roots. I set them equal to 0 to solve. So make sure you can do that. This next worked example, a little different because we have a leading coefficient of something greater than 1. So be careful. Right here they solved. When they take the square root, it's plus or minus 1/3. Let's graph this correctly. So I'm going to put 9 squared minus 1. Let me zoom in a little bit. We're not going to like this. Yeah, it's 0.3333. which is kind of hard. Negative 0.333 and 0.333 positive, which is what they have right here, plus or minus 1/3, which is also my, how can we say it, my zero, okay? Explain why the square root of 1/9 equals to positive or minus 1/3, because 1/3 times 1/3 gives me 1/9. Negative 1/3 times negative 1/3 gives me positive 9 also. Using graphing technology to verify this, is this true? I don't know, let's check. We got the first one down. Let's see if the second part overlaps on top of my graph right now. So we get 9 x minus 1/3. Oops. I don't know if you saw that. If I turn off the second one, I turn it back on, they're right on top of each other, proving that this is our factored form. So, after showing the factored form, are they equivalent? Yes, they are overlapping graphs. Overlapping graphs are right on top of each other, which is good to go. 3 students tried to do this and see which one is correct. Now, they're telling us right here, Terrell and Jackson are already wrong. Why? Because we need the values to equal each other. So if I put this in Desmos, is this going to be the same thing as this? Let's check. Type it in. 9, oh, forgot parentheses. 9x minus 3 times x plus 1/3. Oh, terrific. So it is the same exact line, so this is where it's going to get a little enticing, which is why I'm so happy we have Desmos. So while it is the same line, these, if I solved it correctly, it will not give me 1/3 on each side. So this one would probably give it to me, but if I put this set equal to 0, it's not going to give me what we want as a 0. Okay, Rochelle is correct, because if I did the whole box method, we should get the original function of 9x squared minus 1. I know, don't freak out, not a big fan of this lesson. Obviously, these are our zeros. Our zeros are right here, which are our linear functions that are going something like this. All right, I think we're almost done. Yeah. For each graph, they want us to graph it, and then obviously see our 2 linear factors, and then let's talk about them. Here we go. F of x. Don't be afraid to type in everything. I know A lot of kiddos here at my school are afraid to type in everything. Don't be afraid to type in everything. There's my graph. I'm gonna do my best to graph it on the graph paper they gave me. First, I'm looking at my zeros, negative 1.5 and 1.5. This is a tricky part. How do I want my graph to look like? Are they going by ones? That's the thing. Wish it would have been a little bit numbered. That's okay. Negative 9, 1, 2, 3, 4, 5, exactly. So I messed up. 1, 1.5, 1, 1.5, 1, 2, 3, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we're just gonna graph it nice and neat. And look, it looks beautiful, doesn't it? Just kidding. Okay, so they want us to label the axis of symmetry. Don't forget that's our vertex. Coordinate is 0, negative 9. Axis of symmetry is my x. It's a dashed line going through 0. Okay. Next, my zeros are identified right here. We just saw it's negative 1.5 and 0.5. They're both going positive. So it'll be something like that. And you want to go ahead and do the other two. Okay. I know this video was very odd, not very user-friendly. I guess we can say we just want to make sure we can maximize our Desmos potential. You do have Desmos on the STAR test, so we do want you to be able to identify key components of a quadratic function, okay? On the back side, I definitely recommend you use Desmos for this part and Desmos for this part. A lot of extra practice, okay? Very short videos today, only because there wasn't a lot of material that we enjoyed as a group. So definitely just take the initiative and practice just finding your zeros. Finding your zeros and, you know, making sure that you can put it in vector form correctly, okay? Please have a great day. Can't wait to do lesson 4. Bye-bye.